Okay, it's ready to be shared. So
All right, perfect. All right, so I'm right here on question 16. And it's
using the salt thing, or that's not your problem, I'm assuming.
no, I kind of got down to here and I think I'm doing everything right so far. And then I get down to the draw a picture of the sampling distribution of P hat 1 and P hat 2 or minus P hat 2. And then I'm confused.
Okay, so what you're going to do, if you could scroll that picture up a little bit, because I need to get some numbers. What was P1 hat, take away P2 hat? Let's find out what that should be equal to. So P1 hat, take away P2 hat. So is there some calculation you've got? There you go. What was P1? It was equal to what, 0.53?
Yes.
Right, now if you scroll down, there should be probably something similar with the P2 then.
Yes.
Yeah. And the P2 is what, 0.04?
That's still.
Oh no, that's the difference.
Yeah.
Okay, what was P2 hat? Because I'm not sure that is the right difference.
I was 0.48.
Okay, so if you do 0.48 and you subtract 0.53 from it, you don't get 0.04.
Well, then that's not what I did. Hold on.
Okay, well, I've got.
We can also see if I'll put it in and then we'll see if it's right or not.
Well, it should be 0.05.
So it looks like these ones are right. Oh, it is. I just made a mistake. I have that written down here too. I just clicked the wrong button.
Right, now keep that picture there just for a few seconds because I'm going to then switch over to where I am. So the other number that's going to be important to us is the standard error, which you got correct. Right, now if you can relinquish control again, I'll show you how you would use just those two numbers. Right. Oops, I have to show you my picture for it. Right, so you know the difference is 0.05. So that means the sampling distribution has a mean at 0.05. Now, if it had been P2 take away P1, right? In other words, if that number had been the little guy and this one had been the big one, right? That would have been a negative number and you would have chosen one of the pictures that looked like that. So the sign is important. Now, this fella, you go 1, 2, 3. If you go one of these standard deviations away from here, that number there should be 0.0816. And if you go one this side to it, it would be, that number would be, take that away, 0.0184. And then 2, then 3, then 2, then 3. Pretty much if I know this number and these two, I should be able to figure out who the picture is. Right, now one of those pictures you're looking at, did it have a positive 0.05 in the middle and guys that look like these two either side of it?
Yes, it does. I have one that has the 0.05 and then on the higher end it has 0.82.
Right, so you're wondering where these numbers come from. If you take the mean and you go one standard deviation, standard error is just a name for the standard deviation of the sampling distribution. So you don't think of it as something different, just think of it as the same thing with a different name, right? So, you know, if you start at middle, you go one standard deviation, 2 standard deviations, 3. That's what your picture should look like.
Yeah, and that's what I did for the first one. I guess I just didn't figure that the mean
was 0.05.
Yes, and I think that's where I got confused, which one to use for the middle value.
As an example of what I would suggest you do when the midterm happens is that even although that's a relatively simple calculation, but if you write it down, I will look and say, oh, she can't count. Oh, that's it. Like, that's what we want to see. So when you do your pictures at the end, rather than WebAssign, we'll just look at that and say, you're wrong. I would be able to, hopefully.
If I have all that information like that, you can throw in some partial credit or something.
Exactly. You'll get partial credit for those parts of the process that you were doing correctly.
Okay.
Uh,
So
okay,
on the
Mhm.
so on the other part, it says using the figure you drew in part D, sketch the region that corresponds with P1 being less. So you're just picking the part on the graph where P1 is less than P2. So the one that's shaded, that's
So
less than it.
P1 less than P2.
Yes.
Is that, right, so P1 is less than P2 would be this side, wouldn't it? It would be P1 is smaller, so you'd end up with the numbers that go this way.
Okay, and you go from the mean.
Yes.
Okay, all right. That was all I had for you.
I think, oh, hold on. Is that right? I can't see that. Oh, I'm probably in the wrong question, am I? Can we go back just for I don't want to say something because I've got a sneaking suspicion I may have told you something that's not 100% correct.
Okay, yeah, because they're not going from the mean either.
They're not going, they're going to go from 0.05 to the left.
Okay.
That's what I think they're going to do. But I'll just, yeah, okay. So why are they doing the choices that they have got? We are losing the figure, sketch the region where P1, with P1 being less than P2.
So then are you looking at the, yeah, no, I'm not sure I'm on that one.
Right, if P1 is less than P2, that means I'm looking for negative numbers. And so I'm only looking at negative numbers here. Oh, can you scroll that up or down for a moment? Let me see the choices. Right, go down the other way now, or up, whatever. Yeah, it is the one that we're looking for is the one with 0 in it. So the one that has 0 and everything to the left is the fourth picture.
I'm sorry?
If you look at the pictures, the bottom right-hand corner one, yeah,
So
that blue line, if you imagine where it is located, it's actually located at 0.
Oh, because then it gets
Then
negative.
negative means you're less than. So I'm
Okay.
glad I did double check that.
Okay. Awesome. Well, thank you so much.